of that is wherever you're starting and applying in the candy color spiral. And so you try to say, okay, what is this, this, and this? And then you go, all right. And then it starts going like that. And it gets closer, all right? And then it will spiral out, and then in, out, and then in, out, and then in. And then, you know. All right? And that's actually going away from its base, its start. So, depending on how you look at it, your starting point, your initial starting point, all right, that's always there, and then you're applying something else, that's your second degree, right? You have your 1 degree or your 2 degree, depending on how you're starting your balance, your equality, your base. So, if I'm going out there saying it's a 45-degree angle, all right, I can have a base right here and say this, this, and this, and then I can facilitate aligning a color spectrum to that angle, balancing equal to any number of any other application, whether it be a number 3, 6, 12, 36, 336, all right? And if I'm going to go out 336 this way, then I'm going to go out 336 that way, all right? And that will mean also I will have something that I will either call red, blue, yellow, or any other definition I apply to it that will go ka-cha, all right? 360 all the way out there. And so I will see this spiral, right? And then the spiral will go like this because I'm using the smaller one. Remember, I'm still using, every time I use the second one, whenever I'm using anything beyond red, yellow, blue, any of the primaries, right? Think about that. Ultra, violet, infrared. So right there, I have my my color, okay? And I can have my my X is my color. My Y is out there, all right? So my Y and my Z is my infra or my ultra, infrared, ultrasound, all that stuff. We'll get to that in a second also. So right there, all right, you have that second degree out, okay, because we have our red, infrared, all right. We can have all our infra colors, all right, but right there, red is on the first one. It's a primary, all right. Bam. Okay, so we say violet, violet's bam, second one, right? You gotta have the 6, you know, red, orange, yellow, green, blue, violet, bam. All right, so that has moved out, okay? And not only that, it's moved over, right? Because we are over here with red. Remember, infrared. Bam, this is infrared, right? First time going, okay? And then we went to ultraviolet. Bam, right? We went out. Remember, we're red, and then we went over the violet. All right, so if we're like this is red, right? This is infrared. Now we're ultraviolet. Now see this right here? This is infrared. Ultraviolet, right? Notice how violet's right next to it. Purple, whatever you want to call it, violet. But the thing is, it's closer. Alright? It's further out there. Or it's closer to the camera. So it's further away from red. Why? Because it's on the next level out there, okay? So look how we're not just like, bam, off one and over one. We're out one. Right? You know? So there's our X, Y, Z, our angle, our distance, our degree, whatever you want to call that. And so, right there, you can apply whatever you want with any application of color and math, because you already start out with something. So if you say I have this 45-degree angle of whatever, you can apply that by going out so many degrees in the 360 thing, and baselining your origin point as just red. And here's this color. And so your little red right here, every so many times, is going to keep rotating, all right? 360 times, 360 times, this red is going to rotate, right? It's just going bam, because I'm going 360 out. Remember, if I'm doing the 360-degree circle, all right? So this red's going to go 360 degrees, 360 times, I'm going to have to do this little primary red 360 times, because that's the initial one, right? So that's going to start the spiral. So you may think, hey, wait, this thing's going straight. And we're like, yeah, that's the balance, remember? That's the balance. That's where you balance the Kenny color spiral. That's where you have to apply something and say, what is this? And we're saying, okay, this is red. We're starting here, this is red, all right? And then what happened after that? Oh, we said ultraviolet, all right? Bam! Okay, so then red is actually leading the way, even though we think we're expanding out, right? Because, hey, where does the spiral go, okay? Because if not, it's coming out at us, right? And that's where in the balance you think both ways, right? Remember earlier this, when I was coming that, right? That right there, in the balance, right? So that's where that coming from, right? Because you lead the way with this. So you're just like, if you look at it, you're just like, okay, where am I putting this, all right? Because you expand it in front of you, not away from you, right? How else are you doing it? And then you're thinking, how else are you, however you want to do it, because your mind goes both ways, your left brain and your right brain. Each way could work that way. And so you got to be like, okay, go both. You have to understand the colors that right there. So you have to make two Kenny color spirals, and you understand that if right here is red, all right, and it's starting going this way, right? And I know how many little reds go like this, going that way, all right? I'm going, because remember, it's 3 of those every time, and then you're going to realize that every so many in the 360, it's going to do this many times. Every so many 3 in the 36, it does this many times. Every so many in the 12, it does this so many times. Every so many in the 6, it does it so many times. So it's 1, 2, 4, 36 is 12, and then it's, what is 3 times whatever, that's 1200? Or 120, right? Right? Times 3, right? Because that's how many times it's going in there. Because how many times does 3 go into 6? 2. How many times does, and that's the first degree of separation. And then the second degree of separation, how many times does 3 go into 12? 4. So the second degree of separation, 4, all right? Remember when I talked about grabbing a whiteboard earlier? And then the third degree of separation goes, 36 is 12, all right? And then you go to 360, right? Which is the fourth degree of separation, 120, okay? Now look at that, all right? So 120, you went from like 12 to 120. That's like a really good leap. Mathematically, and it's a color thing. So you the next one, we'll just make it easy and say 3600, 3600. So how many times does 3 go in there, right? So then you're looking at it and you're like, well, you're just adding a 0, right? Think about that. Think about how that mathematically just worked, right? I have this little mathematical thing right there that says, okay, I have to go 1 equals 2, 2 equals 4, 3 equals 12, 4 equals 120, 5 equals 1,200. Notice how when the zeros add, it now becomes a mathematical thing of 10 off a baseline of 3, 6, 12, 36, 360. And you can now understand further mathematics of applying numbers, angles, degrees. What was angle, degree, and distance, arc, x, y, z, whatever that was that we called, smoke more weed, that, more popcorn to drink. All right, we're on really good stuff with Kenny Color Style. All right, so this is what we got going on. Right there, you see that all the different colors that can line up and the mathematical formulas that will go into that and how you can balance the Kenny Color Spiral easily with just like a simple set of balance rules, numbers, and formulas that say, okay, what am I looking at right now? So if I'm looking at the ultraviolet, all right, so at the very least I'm 2 out, okay? Because what if my ultraviolet, excuse me, has its own range? Because remember when we were talking about the circle like this, and my violet's over here, all right? My violet has this, and you may be like, whoa, 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 why isn't my violet all the way out here? And that's where it's like, okay, well, think about this. You have your violet, all right, your purple, whatever you want to call it, your violet, and then you want to have like different types of shades or whatever of violet. So that's where you're going to add it to black and white, most likely. Okay, so you're going to say, pastel violet is like white and violet, right? And then you can say these other things, like when you mix black and yellow together and you get a shade of green, all right? So right there, you can say, okay, look at this Kenny Color Spiral over here that got a shade of green, all right? And it was using black and yellow, because if you mix black and yellow together, you get a style of green, all right? So if you mix blue and yellow together, you get a style of green. If you mix, check this out for violet, purple, violet, orange, green, and red. If you mix orange, green, and red in the right amounts, you know, honestly, you get violet. Or purple. I always say purple, actually. But for here, we're calling it violet because on the on one of those scales, it's infrared, ultraviolet, right? However you want to say it, right? Because depending on whether you're going like this or out like that, right? Because it's like, or even out like that, right? Because remember, there's the angle, the degree, and the distance, right? The x, the y, and the z. And so, that right there, I apply however I want. So if I put, remember, I'm making a violet, all right? So because I have to go say, hey, bam, right here. So I can throw in certain sets of mathematics of whatever that should line up in so many forms that should make it actually pretty easy of sets of numbers in math with saying violet, because look at making violet with orange, green, and red. So I'm using 3 Kenny color spirals right there, right? So I'm going to take this one that only has 3, the primary, but I can't put it first. I gotta put it last, right? Think about that, all right? So the first one has to start with a orange. Orange is yellow and red, okay? So you take 2 small Kenny color spirals and then you can chop, all right? All right, so think about that. You're having red, yellow, all right? And that's your balance going this way. Remember, this is like this X, Y, and this is the Z in the balance, all right? And your X is red, and your Y is your yellow, all right? So, and your Z is your balance. And the thing is, because you're going to have more than that, because the second degree of separation is, what is that, 4? Or 2, right? It has 2. So you have your yellow, red, and your red, yellow. This way, right? You have this way on the balance going this way in your initial balance when you're doing your initial whatever, right? Because the thing is, if you're not having any other colors besides a primary, you leave it at one thing unless you apply something else to it, you know? And you're always going to do that no matter what, depending on your equation, because it's an X, Y, Z, and this could be your X. So you're like right here with whatever color you choose, your infrared, all right? And you're like, bam, I'm only doing my infrared whatever, and then I'm measuring the I don't want to say relativity, but or conductivity, the generality, where it can exist within a mathematical hold while holding on to a same color from a different Kenny color spiral. Because remember, we're talking ultraviolet. So you can make violet from orange, green, and red. So you have first do your orange, so you take your red, yellow, yellow, red, right? Bam, because we automatically know we're going to have at least 2 because we wanted the ultraviolet to begin with. So, and you're like, well, wait, we can already do that with just red and blue, all right? Yeah, we can do that, but that's another form of the Kenny color spiral that could be holding that color, right? So, but we want another form of ultraviolet that's from another Kenny color spiral combination that's more complex to facilitate the utilization of mathematical instruction demo right now. So we're using the violet that is produced by Alright, I just checked the time. It's at 19 minutes. I don't know if it's honestly only been 19. I thought it was longer. So, the Kenny color spiral takes 2 to produce blue, red, violet. Right? The violet from blue and red. And in the other one, it takes orange, so you have 2 right there, which is 4. Sorry, 4 because you have your... This is where I'm a little high and confused. I got a whiteboard, right? Anyways, you have your orange. That's your red and your yellow. There's 2 right there no matter what, alright? And then you have your green, okay? That's your yellow and your blue. There's 4 right there, okay? And then you have your red, so there's 5, alright? So you have these 5 Kenny color spirals holding on, alright? So if you think about it, where they're aligned, okay? So you have, and what would be considered, you have to define each set, alright? And that's another form of math that you have to know about the Kenny color spiral, that I don't even know if some of these have names for them, alright? And they mathematically define like what's up and where they're at by how many factors of Kenny color spirals there are holding a color together, and how you can hold a color together with this, and that's how you can manipulate mathematics, or not manipulate but figure out mathematics by stating, okay, if this is right here on this thing, okay, and this thing, like a frequency, a wavelength, a vibration, anything that can be graphed, or yeah, that you place here, there, this thing, alright? And you're saying, okay, I'm applying anything to it, the color, the degree, the angle, the distance, whatever you want. This color spiral has these mathematical alignments that make things easily to figure out, that you're like, okay, if you want to complete this an activity, something has to be this color, or in this frequency has to be in this pattern. That's something like that. The frequency has to be in this pattern, right? You can understand, here's the frequency, but it has to be in a pattern, right? Anyone can remember a heartbeat, right? Your heartbeat has to have a frequency and a pattern. It's that simple. That's the way it is, right? So that right there, you can apply right in the Kenny color spiral and say, okay, if I wanted to apply a color to that and say this is the good color, all right? And anything outside of that pattern is the bad color, you know? You can do that. And you could basically say anything outside that color, honestly. Because remember, you're in a spiral. So if you're saying, hey, I want ultraviolet, all right? Ultraviolet's my good color when I'm attached to the heart monitor, all right? And it's like, ta-da! And anything that goes outside of my defined frequencies of whatever, of my my heartbeat, you know, it's going to like, hey, not good, not good. Anything out there will be an assigned color, okay? That right there is one way to see a boundary of what is able to be done with a certain color by assigning it boundaries and to the frequency, or by saying this is the measurement I'm going off of. I'm only going to look for in between these angles here by these degrees here from this distance, right? Because that's what that's doing. It's actually spiraling as you're doing all that. So with those degrees, angles, and all that stuff, you go that distance. And remember, each time you're doing something, anything, each Kenny color spiral, you normally go off of a 360 degree one, right? And the 360 degree one, because remember, one is your is right there, right? Oh, and then there's another unit of math. That's right, there's a whole other application of the math thingy, because you have your 1 is 3, your 2 is your 6, your 3 is your 12, Your 4 is your